Jai Hind to all. My name is Aarti Chaudhary. I'm assistant professor in IT department from Akgec Engineering College. And in today's session, we will listen that what is a network layer. We know that there are 7 layers in the OSI model. First one, we have a physical layer. Next, we are having a data link layer, network layer. Then we are having a transport layer, session and presentation layer, and then we have a application layer. So we will see that what the network layer will do, what are the advantages of using a network layer, how that packet will be formed, how it is transferred to the data link layer. So we know that it is sandwiched between the what layer? This is network layer. This is sandwiched between the data link layer, and we are having a transport layer. So we are having a sandwich. How data will come from the transport layer to the network layer, and then the data is formed and sent to the data link layer. So we will see in that sessions. So what are the roles for where we know that the position is sandwiched between data link layer and the transport layer. What are the characteristics of the network layer we are having? The characteristics is we are use a intra working also, routing also. We are using, we know that IP address also. What is assigned to a computer when we using a internet is a IP address. So all that routing algorithms we are having, how the data is transferred from one source to destination by using IPs, by using the logical addressing also. So how do we do the packetization, how the packet will be formed, all the headers and footers has to be attached in the packet, and then the packet is transferred from source to destination. The data is also fragmented because we know that the data is been a long data, so you have to be fragmented, and the first it is disassembled at the receiver side. So how the data is being disassembled at the receiver side and the fragmented, we are having also a flag bit. According to that, we will see in the IP version 4 that these flag bits is to be don't fragment and more fragment. So we will write in every packet that this is the last packet, this is the first packet, this is the middle packet, by using these flags into it. So all these are the things. What are the addressing what we are using? We are using the logical addressing. Logical addressing, we are having a IP address. When we know that and our data has to be transformed from the source to destination, then data has to be having a source address also and destination address also. So that has to be mentioned into a addressing mode. Then we are having a routing algorithms also and packetization also. All these things we will see in a network layer. So we will see the small part of that is a IP address here. What is IP address? So how do we deal with IP address? What are the parameters to be seen at the IP address? Subnetting will be also seeing that. So all these things we are seeing that. So these are the duties, these are the services of the network layer we are using here. So we will discuss here IP version 4 address. IP version 4 is to be in 32 bits. You know that 32 bits, 32-bit address we are having uniquely and universally accepted. No two computers have the same IP address in when we are having a computer. So all these are topic we will discuss in what are the address space of it, what are the notations used in it, what is classless addressing, what is classful addressing, what is a network address translation. All these has to be discussed into it. The IP version 4 is a 32-bit long. It is to be having a 888-bit. So we have 8.8.8.8. So all these 8s has to be have a 32-bit long is equals to 32-bit long IP version 4. We are having a IP version 6 also, but it is currently not is used. But we know that IP version 4 6 has to be 128 bits. 128. So definitely it will in the future it will come into a picture when all the IPs has to be mentioned, because how many IPs it is possible? 2 raised to power 32 IPs addresses will be possible. So after that, what we as a solution is IP version 6 we as a solution. This is uniquely and universally defined. No two IPs of the computers has to be same. We are having. So we are having how much address space of it? So IP version 4 is to be 2 raised to power 32. That is, we are having this much IPs as has to be possible. So that is dynamic also or static also IP, where we have a dynamic. When we are running a computer, we will have a IP, and then when we detach from the computer, we don't have an IP of it. But static IPs are when we are using a www.google.com. So that is fixed IP is given to that. facebook.com, instagram.com. So all these IPs are fixed, that is static, we are having here. So all that is, we are have to divide it. This is a 8-bit, 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 and 8-bit. So all this are separated by the 3 dots, 1, 2, and 3 dots, and we are having a dotted form of this. So this is a binary representation of it, and this is a decimal representation of it. So with what we have changed the IP address of the binary location this, so we will having a change in the binary to a decimal. How we are changing 0, 1, 2, 3, 4, 5, 6, and 7. So that is equals to what is this? 2 raised to power 7 plus 2 raised to power 0, that is 128 plus 1, that is 129. So that is come here. So all that 1, 2, 3, 4 up to 7, all because 0 to 7, that is 255 is only possible. Every IP will be range from 0 to 255, not 256. 255 is a range from it. Every 8-bit number will go from 0 to 255. So we will having this numbers also and B number also, but 8-bit equal to. Then what we are having, we have to convert this into a binary decimal into a binary. How will we convert it? We will having a number that is, for example, 7 we have to divide this by 2. We have 3 is a 1, 2. We will write it here as a 1 and 1. So we will write from the bottom to top, we will write it 1, 1, 1. That is the number is 1, 1, 1, and we will have a 3 numbers 1, 2, 3, 4, 5, 6. 6 zeros we will put here, and 5 zeros we will put in, and 3 is a 1. So we will make a octet because we have to make a 8-bit number. So we have to write every decimal into a 8-bit number. So that is the why we are having a decimal to binary conversion. So you can see that we will write a binary to decimal and decimal to binary conversion of it. Then what is a IP? Which one is correct IP? What you see is that this is also correct. This is also correct. We can't write 0 in the front of any. 45 is written. If 045 is written, it's not applicable. So this is not a IP address. 1, 2, 3, 4, 5. We can't write it because this is the extra one, because we are having 32-bit, not the excess one of it. This is not the right way to look, because we have know that it will range from 0 to 255. So this is a 301. It is not in a range. So that's why this was not a valid IP. And next is, this is a binary representation. This is a decimal representation. Though they are not having a we are in IP, though both representation is not there. So we have a binary also and decimal also. So this is not a mixture of the binary and decimal representation is not allowed. So all these 4 have a not a IP, valid IP addresses. So we are having a addressing is a classful addressing we are using. We are dividing into a B, C, D, E part, where we divided a IPs. So the IP which is from the 0, starting with 0, and which range from 0 to 127 is from the class A class. Then if the first 2 bits is 10, it will start from 128 to 191. And 110, say it start with 192 to 223, and next is 1110, it's the binary representation, and there's a decimal representation in 224 to 239, and 111 we are having a 240 to 255. So this is a binary representation, how we can differentiate between A, B, C, D, E class. And this is a decimal representation, maybe going from 0 to 127 to 0 to 255. How can we go for it? So when we have to identify that what is the class we are using in it, so first we are having that first bit is 0. So what is the class name is? That is a A class. If it's 110, so what class is it is to be? So that has to be C class. If it is 14, so it is from A class. If this is from E class. So we will see that if it's a binary representation, we will say the zeros and 1. If it's a decimal representation, we will see the range, which was seen earlier also. Okay, that is used for the. So this is a binary representation, and we are having this as a decimal representation of it. Then we are having the blocks that the A, B, C, D are the unicast application. This is multicast, and this is reserved for the defense purpose. So how much block size we are having, number of blocks, it will be set from A class to from class A to C. It will increase. From this to this will increase block size will, because this is the power of this. This is the power of this. Okay. So when we are using a classful addressing, we are fixed that this is a host we are having, this is a network we are having, this is subnetting we are having. But when we are using a practically using it addressing in IP, so there was not a restriction, because we are having that in the class A we know that there was only 8 bit for the network ID, and the next dot 8 dot 8 dot 8, all these bits are to be host ID. So that has to be 2 raised to power 8 is the network we are assemble, and 2 raised to power 24 is to be a host ID we are having. So we are having fixed that we have 2 raised to power 24. If we want 2 raised to power 30 host into it, but we can use it because we are having range of this. So we are having we will have, for example, a company demands that network has to be decreased by 2. That is, the company demands 2 raised to power 6 network and 2 raised to power 26 host we are having. So how can we do it? How can we make it that this network has to be less and this has to be, because in the classful addressing, classless addressing, we are not having that. Then we are having a making that classful addressing is a completely wastage of engine. So then we are come to a picture of the classless addressing. So class addressing is replaced and is to be working into today's scenario. So we are having a notation. What we are having is so small organization. We need a 16 addresses, and 16 addresses has to be 2 to power 4, that is 16 addresses. So how many we can see that what are the results of it. So we will start from any IP which is far from 32, because 32 divided by 16 is equals to 2. So this is where we will start with our IPs, and it will go in increasing, because we have to, this is the first address and this is the last address we are having. So we have increased plus 16 have addresses we will assign to it. So this is the making. So when we are using classless addressing, we will use a x dot y dot z dot t slash n, where we are having that these are the things which we will use in our thing, that is the IP address we were using. But this is a mask what we are using. If we are making 21, so that 21 is equals to 21 is a network address, and when we write it down, 32 minus 21, that is 11. 11 is a host address. So in that, but in the case of A, B, C, that is a classful addressing, we know that, okay, that A, B, C, we are having 8-bit network. Oh, sorry, we will write it network here and host here. So we will write 8, 24, 16, 16, or 24 and 8 we are having. So in that case, what we are having is that 8, this is fixed when we are class using A. So it is of 8-bit network and then 24-bit of version. But when we are using a classful classless addressing, what we have to do is what we are using with the mask of it. If it's 21, 22, not the multiple of the 2, because these are not the multiple of 2. When we are taking 21, 6, 17, 18, 19, all these are the classless addressing we are using. So we will write it, if when we want to write our first address, what we use the right most bit is to be 32 minus n bit has to be zeros. When we writing if this is a IP address, and what we have to write it the first address, what will is the 28 is a network ID. 32 minus 28, that is a 4, 5, 6, 6. Sorry, 6, we are 6 as a host ID. So we will write a 4s. So these are 4s, 4 has to be zeros. So all these 4s, when we are writing this into a binary one, all these 4, 1, 2, right from the right hand side. For 1, 2, 3, 4, all 4 has to be zeros, and all that 1 has to be there. So 0, 0, 0, 0, 0, and we are having a 0 here. So this is the equivalent of this. When we are going for a last address, what we write most inside. all the n 2 raised to power n minus bits from the right hand side has to be ones. So that is the right hand side, all that 4 bits has to be 1. So that is mentioned. So it will range from where 32 to 147. So we will see that also in the previous case also. This is 32 to 17. This is compared. We will see that when any network will come into a picture, it will give a first address and last address. First address will be coming from that when we are a host ID, make it all zeros, that is a first address. Making all ones is a last address. Okay. So yeah, this is the number of addresses to be 2 raised to power 32 minus n. So we have had 32 minus 28, that is a 16 address is possible into a case of 2 raised to power when we are has mask of 28. So when we are having a first address, last address of any, so we are having a first address to last address when we are having a previous example. Having. So when we are having a mask address also, this is a equivalent binary equivalent of decimal one. So this and mask is what? When we are making the network, how much network we are having? Network ID is we are having 28, and host ID which we are having is what? Host ID is we are having a 28 4. So making all these 4 and all these 28 to be ones. This is a subnet mask. This is a subnet mask when we are having. So when we are making this, making ANDing operation. ANDing is 0 when 1 1 0 is 0, 0 1 is 0, 0 0 is 0, 1 1 is 1. This is the operation we are ANDing and making a result 0. This is a first address. When we are having a ORing operation with the subnet mask, so we are complementing 28 zeros, ones to zeros, and all zeros to 1, and then making a OR operation to it. OR is 0 0 0 and 0 1 1 0 and 1 1 all to be 1. So we are making a first address. This is also way to find out the first address and last address of a range of the network. So this is this, and we are complementing. We are having a 15. This is 15 bit. 15 plus 1, 16 is to be number of addresses we are having into it. So this is a block where we are having a first address, last address, and this is a total number of addresses, 16 address we are having into it. So first address is not assigned to any because it is an organization address, and we will use for the loop back address. The first address will not assign to it. So we are having our condition is that we are having a computer organization have a condition that we are having a ICP. This is a IP address we are using. We are know that the network address is to be 16. The host address is to be 16. So what is the first group? We know that 64 customers we need, or 256 addresses we need. First group is 128 to 128 or 128 to 60. So we have to deliver the sub address and how many address will be there. So we will see that what is the IP address and what are the number of this. So we will see that in the first case, that is a first case we are having 64 to 255 addresses to. So 64 addresses, what we have is 64 with having an address of this. So what we have in this group, we have each customer 256. So her ko we have a 8 bit is used for this. So 32 minus 8 is equals to what we are having is 24. So 24 is a network address, and 8 we will use a 8 as a host address. So what will see that you will see that 64 customers, and in each every customer what will be 0 to 256, 0 to 256, 0 to 256. Matlab 64 into 256 is this much total addresses we can accumulate it. So this is the last address 190, 100, 63. We will start from this also. And what is the condition is 64 or 128 or 128. 128 or 128. तो 128 का कहने तो 7, तो 7 bits are used for this. तो यहाँ पे 0 to 127, 128 to 255, all that 0 to 128 into 128, this much addresses we can accumulate it, because 32 minus 7 is 25 bit, we can use it here 24 bits, because यहाँ पे addresses थे 256, so 8 bit we are using for host, but here we are having 7 bits for the host we are using, so we are using a 25 bits of it. Okay, next we are having a say 128 by 64. 64, how much? We are using 6. So 32 minus 6, 26. So we are having a 26 ID. So 128, 64 to this is the total number of addresses we are used by the IP here. So we are granted ICM 65,000 address, 40 are used, and this 24 are available when you as a user class less addressing into it. So these are the group from customer 1 to customer 2, customer 3, customer 4. These are the grant address from the computer internet by the ICMP. This is a range of the private networks. Private network from this to this is 2 raised to power 24. This to this and this to this are the private IPs which is assigned to an organization when they can be able to purchase it. So we are our NAT implementation also. These are the site using the private IP India router we are having, and this is the internet. How can we communicate by this? By using a IP 224.5.8. So now the data has to be covered addressing. We are having a source. Then when we are going for an NTA server here, router here, it will change to a one. This the source is this. When coming from destination this, then it will change for destination this. So from private to public, this is a change in a by using a NTA router here. NTA router. This is a procedure what we are doing here. Okay, this is a translation of when we have to send it. So every private network have this. So this has to be private, and this is the external we are having external. So that addresses has to be updated accordingly. That we are having have to update. This is a private source we are having, and this is a destination we are having. But at the time of entry, the source has to be changed. This is changed, but the destination is same. When then it coming from this, the destination is this and the source is this. So that has to be also a change, because NTA routers will change because they have to preserve the identities of the source and destination accordingly. So in this PPT, we will see that what are the private network, what are the classful addressing, classless addressing, what are the IP, valid IPs we are having, how much addressing we are having, classless addressing, classful addressing. All these are to be covered into this topic. Okay, so all these are the ICPA networks, what we are having a private networks, ICPA sites. These are the addresses we will go for the internet connection. So ICMP will give our IPs, and then after IPs will interact with NAT servers to it. Okay, and thank you.